History and nature. Mars, the planet. Mars is the fourth planet and the furthest terrestrial planet from the Sun. The reddish color of its surface is due to finely grained iron oxide dust in the soil, giving it the nickname the Red Planet. There is a sharp contrast between the two Martian hemispheres. The northern hemisphere is on average flatter and smoother than the southern hemisphere. The planet's two poles are covered by water and carbon dioxide ice caps. Surrounding the Martian surface is a dynamic thin atmosphere, 1% of Earth's surface pressure, made primarily of carbon dioxide. Mars has two irregularly shaped natural satellites, Phobos and Deimos. Mars has a mean radius of 3,389.5 kilometers, 2,106 miles, the second smallest among planets in the solar system. The gravity on its surface is about 3.72 meters per square second, 12.2 feet/s2, which is 38% of Earth's. The temperature on the Martian surface usually ranges from -110 degrees Celsius -166 degrees Fahrenheit to 35 degrees Celsius 95 degrees Fahrenheit. Geologically, Mars is fairly active, with dust devils sweeping the landscape and Marsquakes trembling in the ground, a Martian analog to earthquakes. The surface of Mars also hosts the highest mountain, Olympus Mons, and one of the largest canyons in the solar system, Valles Marineris. Days and seasons on Mars are comparable to those of Earth, with a day length of 24.5 hours, a year length of 1.88 Earth years, and an axial tilt only slightly greater than Earth's. Like the other planets, Mars was formed 4.5 billion years ago. The internal structure of Mars is thought to be composed of an outer crust, a mantle made of silicates, and an inner liquid core. During the Noachian period from about 4.1 to 3.7 billion years ago, Mars's surface was marked by meteor impacts, valley formation, erosion, and the possible presence of water oceans. The Hesperian period from 3.7 to 3.2 to 2 billion years ago was dominated by widespread volcanic activity and flooding that carved immense outflow channels. The Amazonian period, which continues today, was marked by the wind's influence on geological processes. It is not yet known whether life has ever existed on Mars. Mars is among the brightest objects in Earth's sky, with considerable cultural significance. The name Mars is that of the Roman god of war. Its high contrast albedo features make it an attractive target for viewing with a telescope. Since the late 20th century, Mars has been explored by uncrewed spacecraft and rovers, with the first flyby by the Mariner 4 probe in 1965, the first Mars orbiter by the Mars 2 probe in 1971, and the first landing by the Viking 1 in 1976. As of 2023, there are at least 11 active probes orbiting Mars or at the Martian surface. Currently, Mars is an attractive target for the first future interplanetary human missions. Natural history. Scientists have theorized that during the solar system's formation, Mars was created as the result of a random process of runaway accretion of material from the protoplanetary disk that orbited the Sun. Mars has many distinctive chemical features caused by its position in the solar system. Elements with comparatively low boiling points, such as chlorine, phosphorus, and sulfur, are much more common on Mars than Earth. These elements were probably pushed outward by the young Sun's energetic solar wind. After the formation of the planets, all were subjected to the so-called late heavy bombardment. About 60% of the surface of Mars shows a record of impacts from that era, whereas much of the remaining surface is probably underlain by immense impact basins caused by those events. There is evidence of an enormous impact basin in the northern hemisphere of Mars, spanning 10,600 by 8,500 kilometers, 6,600 by 5,300 miles, or roughly 4 times the size of the Moon's South Pole Aitken Basin, the largest impact basin yet discovered. This theory suggests that Mars was struck by a Pluto-sized body about 4 billion years ago. The event, thought to be the cause of the Martian hemispheric dichotomy, created the smooth Borealis Basin that covers 40% of the planet. The geological history of Mars can be split into many periods, but the following are the three primary periods. Noachian period, formation of the oldest extant surfaces of Mars, 4.5 to 3.5 billion years ago. Noachian age surfaces are scarred by many large impact craters. The Tharsis Bulge, a volcanic upland, is thought to have formed during this period, with extensive flooding by liquid water late in the period. Named after Noach's Terra. Hesperian period, 3.5 to between 3.3 and 2.9 billion years ago. The Hesperian period is marked by the formation of extensive lava plains. Named after Hesperia Planum. Amazonian period, between 3.3 and 2.9 billion years ago to the present. Amazonian regions have few meteorite impact craters, but are otherwise quite varied. Olympus Mons formed during this period, with lava flows elsewhere on Mars. Named after Amazonas Planitia. Geological activity is still taking place on Mars. The Athabasca VS is home to sheet-like lava flows created about 200 Maya. Water flows in the Grabens called the Cerberus Fossae occurred less than 20 Maya, indicating equally recent volcanic intrusions. The Mars Reconnaissance Orbiter has captured images of avalanches. Physical characteristics. Mars is approximately half the diameter of Earth, with a surface area only slightly less than the total area of Earth's dry land. Mars is less dense than Earth, having about 15% of Earth's volume and 11% of Earth's mass, resulting in about 38% of Earth's surface gravity. The red-orange appearance of the Martian surface is caused by ferric oxide, or rust. It can look like butterscotch. Other common surface colors include golden, brown, tan, and greenish, depending on the minerals present. Internal structure. Like Earth, Mars has differentiated into a dense metallic core overlaid by less dense materials. Current models of its interior imply a core consisting primarily of iron and nickel with about 16 to 17% sulfur. This iron, too, sulfide core is thought to be twice as rich in lighter elements as Earth's. The core is surrounded by a silicate mantle that formed many of the tectonic and volcanic features on the planet, but it appears to be dormant. Besides silicon and oxygen, the most abundant elements in the Martian crust are iron, magnesium, aluminium, calcium, and potassium. The average thickness of the planet's crust is about 50 kilometers, 31 miles, with a maximum thickness of 125 kilometers, 78 miles. By comparison, Earth's crust averages 40 kilometers, 25 miles, in thickness. Mars is seismically active. In 2019, it was reported that InSight, now offline, had detected and recorded over 450 Marsquakes and related events. In 2021, it was reported that based on 11 low-frequency Marsquakes detected by the InSight lander, the core of Mars was indeed liquid and had a radius of about 1830 plus or minus 40 km and a temperature around 1900 to 2000 K. The Martian core radius is abnormally large, accounting for more than half the radius of Mars and about half the size of the Earth's core. To this, it has been suggested that the core contains some amount of lighter elements like oxygen and hydrogen in addition to the iron-nickel alloy and about 15% of sulfur. The core of Mars is overlaid by the rocky mantle, which does not seem to have a thermally insulating layer analogous to the Earth's lower mantle. The Martian mantle appears to be solid down to the depth of about 500 kilometers, where the low-velocity zone, partially melted asthenosphere, begins. Below the asthenosphere, the velocity of seismic waves starts to grow again, and at the depth of about 1,050 kilometers lies the boundary of the transition zone extending down to the core. History and nature. Mars, the planet. Mars is a terrestrial planet with a surface that consists of minerals containing silicon and oxygen, metals, and other elements that typically make up rock. The Martian surface is primarily composed of tholeiitic basalt, although parts are more silica-rich than typical basalt and may be similar to andesitic rocks on Earth, or silica glass. Regions of low albedo suggest concentrations of plagioclase feldspar, with northern low albedo regions displaying higher than normal concentrations of sheet silicates and high silicon glass. Parts of the southern highlands include detectable amounts of high calcium pyroxenes. Localized concentrations of hematite and olivine have been found. Much of the surface is deeply covered by finely grained iron, oxide dust. Although Mars has no evidence of a structured global magnetic field, observations show that parts of the planet's crust have been magnetized, suggesting that alternating polarity reversals of its dipole field have occurred in the past. This paleomagnetism of magnetically susceptible minerals is similar to the alternating bands found on Earth's ocean floors. One theory, published in 1999 and re-examined in October 2005, with the help of the Mars Global Surveyor, is that these bands suggest plate tectonic activity on Mars 4 billion years ago, before the planetary dynamo ceased to function and the planet's magnetic field faded. The Phoenix lander returned data showing Martian soil to be slightly alkaline and containing elements such as magnesium, sodium, potassium, and chlorine. These nutrients are found in soils on Earth. They are necessary for growth of plants. Experiments performed by the lander showed that the Martian soil has a basic pH of 7.7 and contains 0.6% of the sulfur chlorate, concentrations that are toxic to humans. Streaks are common across Mars and new ones appear frequently on steep slopes of craters, troughs, and valleys. The streaks are dark at first and get lighter with age. The streaks can start in a tiny area, then spread out for hundreds of meters. They have been seen to follow the edges of boulders and other obstacles in their path. The commonly accepted theories include that they are dark underlying layers of soil revealed after avalanches of bright dust or dust devils. Several other explanations have been put forward, including those that involve water or even the growth of organisms. Radiation levels on the surface are on average 0.64 millisieverts of radiation per day, and significantly less than the radiation of 1.84 millisieverts per day or 22 millirads per day during the flight to and from Mars. For comparison, the radiation levels in low Earth orbit, where Earth's space stations orbit, are around 0.5 millisieverts of radiation per day. Hellas Planitia has the lowest surface radiation at about 0.342 millisieverts per day, featuring lava tubes southwest of Hadriacus Mons with potentially levels as low as 0.064 millisieverts per day. History and nature, Mars the planet. Geography and features. Although better remembered for mapping the Moon, Johann Heinrich Madler and Wilhelm Beer were the first areographers. They began by establishing that most of Mars's surface features were permanent and by more precisely determining the planet's rotation period. In 1840, Madler combined 10 years of observations and drew the first map of Mars. Features on Mars are named from a variety of sources. Albedo features are named for classical mythology. Craters larger than roughly 50 kilometers are named for deceased scientists and writers and others who have contributed to the study of Mars. Smaller craters are named for towns and villages of the world with populations of less than 100,000. Large valleys are named for the word Mars or star in various languages. Smaller valleys are named for rivers. Large albedo features retain many of the older names but are often updated to reflect new knowledge of the nature of the features. For example, Nix Olympica, the snows of Olympus, has become Olympus Mons, Mount Olympus. The surface of Mars as seen from Earth is divided into two kinds of areas, with differing albedo. The paler plains covered with dust and sand rich in reddish iron oxides were once thought of as Martian continents and given names like Arabia Terra, Land of Arabia, or Amazonas Planitia, Amazonian Plain. The dark features were thought to be seas, hence their names Mare Erythraeum, Mare Serenum and Aurora Sinus. The largest dark feature seen from Earth is Syrtis Major Planum. The permanent northern polar ice cap is named Planum Boreum. The southern cap is called Planum Australe. Mars's equator is defined by its rotation, but the location of its prime meridian was specified, as was Earth's, at Greenwich, by choice of an arbitrary point. Madler and Beer selected a line for their first maps of Mars in 1830. After the spacecraft Mariner 9 provided extensive imagery of Mars in 1972, a small crater, later called Airy 0, located in the Sinus Meridiani, Middle Bay or Meridian Bay, was chosen by Merton Davies, Harold Masser Sky, and Gerard de Vaucouleurs for the definition of 0.0 degrees longitude to coincide with the original selection. Because Mars has no oceans and hence no sea level, a zero-elevation surface had to be selected as a reference level. This is called the areoid of Mars, analogous to the terrestrial geoid. 0 altitude was defined by the height at which there is 610.5 pascals, 6.105 bar, of atmospheric pressure. This pressure corresponds to the triple point of water, and it is about 0.6% of the sea level surface pressure on Earth, 0.006 atm. For mapping purposes, the United States Geological Survey divides the surface of Mars into 30 cartographic quadrangles, each named for a classical albedo feature it contains. In April 2023, the New York Times reported an updated global map of Mars based on images from the HOPE spacecraft. A related, but much more detailed, global Mars map was released by NASA on April 16, 2023. History and Nature, Mars the Planet. Volcanoes. The vast upland region Tharsis contains several extinct volcanoes, which include the shield volcano Olympus Mons, Mount Olympus. The edifice is over 600 kilometers, 370 miles, wide. Because the mountain is so large, with complex structure at its edges, giving a definite height to it is difficult. Its local relief, from the foot of the cliffs which form its northwest margin to its peak, is over 21 kilometers, 13 miles, a little over twice the height of Mauna Kea as measured from its base on the ocean floor. The total elevation change from the plains of Amazonas Planitia, over 1,000 kilometers, 620 miles, to the northwest, to the summit approaches 26 kilometers, 16 miles, roughly 3 times the height of Mount Everest, which in comparison stands at just over 8.8 kilometers, 5.5 miles. Consequently, Olympus Mons is either the tallest or second tallest mountain in the solar system. The only known mountain which might be taller is the Rhea Silvia peak on the asteroid Vesta, at 20 to 25 kilometers, 12 to 16 miles. Impact topography. The dichotomy of Martian topography is striking. Northern plains flattened by lava flows contrast with the southern highlands, pitted and cratered by ancient impacts. It is possible that, 4 billion years ago, the northern hemisphere of Mars was struck by an object 1/10 to 2/3 the size of Earth's moon. If this is the case, the northern hemisphere of Mars would be the site of an impact crater 10,600 by 8,500 kilometers, 6,600 by 5,300 miles, in size, or roughly the area of Europe, Asia, and Australia combined, surpassing Utopia Planitia and the Moon's south pole Aitken Basin as the largest impact crater in the solar system. Mars is scarred by a number of impact craters, a total of 43,000 craters with a diameter of 5 kilometers, 3.1 miles, or greater have been found. The largest exposed crater is Hellas, which is 2,300 kilometers, 1,400 miles, wide and 7,000 meters, 23,000 feet, deep, and is a light albedo feature clearly visible from Earth. There are other notable impact features, such as Chryse, which is around 1,800 kilometers, 1,100 miles, in diameter, and Isidis, which is around 1,500 kilometers, 930 miles, in diameter. Due to the smaller mass and size of Mars, the probability of an object colliding with the planet is about half that of Earth. Mars is located closer to the asteroid belt, so it has an increased chance of being struck by materials from that source. Mars is more likely to be struck by short-period comets, i.e., those that lie within the orbit of Jupiter. Martian craters can have a morphology that suggests the ground became wet after the meteor impacted. History and Nature, Mars the Planet. Tectonic sites. The Large Canyon, Valles Marineris, Latin for Mariner Valleys, also known as Agathodemon in the Old Canal maps, has a length of 4,000 kilometers, 2,500 miles, and a depth of up to 7 kilometers, 4.3 miles. The length of Valles Marineris is equivalent to the length of Europe and extends across 1/5 the circumference of Mars. By comparison, the Grand Canyon on Earth is only 446 kilometers, 277 miles, long and nearly 2 kilometers, 1.2 miles, deep. Valles Marineris was formed due to the swelling of the Tharsis area, which caused the crust in the area of Valles Marineris to collapse. In 2012, it was proposed that Valles Marineris is not just a graben, but a plate boundary where 150 kilometers, 93 miles, of transverse motion has occurred, making Mars a planet with possibly a two tectonic plate arrangement. Holes and caves. Images from the Thermal Emission Imaging System, THEMIS, aboard NASA's Mars Odyssey orbiter have revealed 7 possible cave entrances on the flanks of the volcano Arsia Mons. The caves, named after loved ones of their discoverers, are collectively known as the Seven Sisters. Cave entrances measure from 100 to 252 meters, 328 to 827 feet, wide, and they are estimated to be at least 73 to 96 meters, 240 to 315 feet, deep. Because light does not reach the floor of most of the caves, they may extend much deeper than these lower estimates and widen below the surface. Dina is the only exception. Its floor is visible and was measured to be 130 meters, 430 feet, deep. The interiors of these caverns may be protected from micrometeoroids, UV radiation, solar flares, and high-energy particles that bombard the planet's surface. History and nature. Mars, the planet. Atmosphere. Mars lost its magnetosphere 4 billion years ago, possibly because of numerous asteroid strikes, so the solar wind interacts directly with the Martian ionosphere, lowering the atmospheric density by stripping away atoms from the outer layer. Both Mars Global Surveyor and Mars Express have detected ionized atmospheric particles trailing off into space behind Mars, and this atmospheric loss is being studied by the MAVEN orbiter. Compared to Earth, the atmosphere of Mars is quite rarefied. Atmospheric pressure on the surface today ranges from a low of 30 pascals (0.0044 psi) on Olympus Mons to over 1,155 pascals (0.1675 psi) in Hellas Planitia, with a mean pressure at the surface level of 600 pascals (0.087 psi). The highest atmospheric density on Mars is equal to that found 35 kilometers, 22 miles, above Earth's surface. The resulting mean surface pressure is only 0.6% of Earth's 101.3 kilopascals, 14.69 psi. The scale height of the atmosphere is about 10.8 kilometers, 6.7 miles, which is higher than Earth's 6 kilometers, 3.7 miles, because the surface gravity of Mars is only about 38% of Earth's. The atmosphere of Mars consists of about 96% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. The atmosphere is quite dusty, containing particulates about 1.5 m in diameter, which give the Martian sky a tawny color when seen from the surface. It may take on a pink hue due to iron oxide particles suspended in it. 20. The concentration of methane in the Martian atmosphere fluctuates from about 0.24 ppb during the northern winter to about 0.65 ppb during the summer. Estimates of its lifetime range from 0.6 to 4 years, so its presence indicates that an active source of the gas must be present. Methane could be produced by non-biological process such as serpentinization involving water, carbon dioxide, and the mineral olivine, which is known to be common on Mars, or by Martian life. Compared to Earth, its higher concentration of atmospheric CO2 and lower surface pressure may be why sound is attenuated more on Mars, where natural sources are rare apart from the wind. Using acoustic recordings collected by the Perseverance rover, researchers concluded that the speed of sound there is approximately 240 meters per second for frequencies below 240 Hz, and 250 meters per second for those above. Auroras have been detected on Mars. Because Mars lacks a global magnetic field, the types and distribution of auroras there differ from those on Earth. Rather than being mostly restricted to polar regions as is the case on Earth, a Martian aurora can encompass the planet. In September 2017, NASA reported radiation levels on the surface of the planet Mars were temporarily doubled, and were associated with an aurora 25 times brighter than any observed earlier, due to a massive and unexpected solar storm in the middle of the month. History and nature, Mars the planet. Climate. Of all the planets in the solar system, the seasons of Mars are the most Earth-like, due to the similar tilts of the two planets' rotational axes. The lengths of the Martian seasons are about twice those of Earth's because Mars's greater distance from the Sun leads to the Martian year being about 2 Earth years long. Martian surface temperatures vary from lows of about -110 degrees Celsius -166 degrees Fahrenheit to highs of up to 35 degrees Celsius 95 degrees Fahrenheit in equatorial summer. The wide range in temperatures is due to the thin atmosphere which cannot store much solar heat, the low atmospheric pressure, about 1% that of the atmosphere of Earth, and the low thermal inertia of Martian soil. The planet is 1.52 times as far from the Sun as Earth, resulting in just 43% of the amount of sunlight. If Mars had an Earth-like orbit, its seasons would be similar to Earth's because its axial tilt is similar to Earth's. The comparatively large eccentricity of the Martian orbit has a significant effect. Mars is near perihelion when it is summer in the southern hemisphere and winter in the north, and near aphelion when it is winter in the southern hemisphere and summer in the north. As a result, the seasons in the southern hemisphere are more extreme and the seasons in the northern are milder than would otherwise be the case. The summer temperatures in the south can be warmer than the equivalent summer temperatures in the north by up to 30 degrees Celsius 54 degrees Fahrenheit. Mars has the largest dust storms in the solar system, reaching speeds of over 160 kilometers per hour, 100 miles per hour. These can vary from a storm over a small area to gigantic storms that cover the entire planet. They tend to occur when Mars is closest to the Sun and have been shown to increase the global temperature. History and nature, Mars the planet. Hydrology. Water in its liquid form cannot exist on the surface of Mars due to low atmospheric pressure, which is less than 1% that of Earth, except at the lowest of elevations for short periods. The two polar ice caps appear to be made largely of water. The volume of water ice in the south polar ice cap, if melted, would be enough to cover the entire surface of the planet with a depth of 11 meters, 36 feet. Large quantities of ice are thought to be trapped within the thick cryosphere of Mars. Radar data from Mars Express and the Mars Reconnaissance Orbiter, MRO, show large quantities of ice at both poles and at middle latitudes. The Phoenix lander directly sampled water ice in shallow Martian soil on July 31, 2008. Landforms visible on Mars strongly suggest that liquid water has existed on the planet's surface. Huge linear swathes of scoured ground, known as outflow channels, cut across the surface in about 25 places. These are thought to be a record of erosion caused by the catastrophic release of water from subsurface aquifers, though some of these structures have been hypothesized to result from the action of glaciers or lava. One of the larger examples, Ma'adim Vallis, is 700 kilometers, 430 miles, long, much greater than the Grand Canyon, with a width of 20 kilometers, 12 miles, and a depth of 2 kilometers, 1.2 miles, in places. It is thought to have been carved by flowing water early in Mars's history. The youngest of these channels are thought to have formed only a few million years ago. Elsewhere, particularly on the oldest areas of the Martian surface, finer scale, dendritic networks of valleys are spread across significant proportions of the landscape. Features of these valleys and their distribution strongly imply that they were carved by runoff resulting from precipitation in early Mars history. Subsurface water flow and groundwater sapping may play important subsidiary roles in some networks, but precipitation was probably the root cause of the incision in almost all cases. Along crater and canyon walls, there are thousands of features that appear similar to terrestrial gullies. The gullies tend to be in the highlands of the southern hemisphere and to face the equator, all are poleward of 30 degrees latitude. A number of authors have suggested that their formation process involves liquid water, probably from melting ice, although others have argued for formation mechanisms involving carbon dioxide frost or the movement of dry dust. No partially degraded gullies have formed by weathering and no superimposed impact craters have been observed, indicating that these are young features, possibly still active. Other geological features, such as deltas and alluvial fans preserved in craters, are further evidence for warmer, wetter conditions at an interval or intervals in earlier Mars history. Such conditions necessarily require the widespread presence of crater lakes across a large proportion of the surface, for which there is independent mineralogical, sedimentological, and geomorphological evidence. Further evidence that liquid water once existed on the surface of Mars comes from the detection of specific minerals such as hematite and goethite, both of which sometimes form in the presence of water.